In section 7.2, we're going to take some time and we're going to find the volume of a figure that we're going to revolve around either the x or the y-axis. So in this video, I want to spend a little bit of time looking at what these figures are going to look like and how we may be able to develop a formula. So here, notice up here I have f of x equals x squared as my function. I'm going to revolve this around the x-axis. Well, what does that mean? It means I'm going to go very quickly around the x-axis as fast as I possibly can. And this is going to make a three-dimensional figure. So when I do that, revolving it, notice there's my figure. And it'll fill in here shortly. But then I want you to think about your eyes being centered on that x-axis, say about at 4. And what figure do you see? And hopefully you see that we have a circle. If we were to peel just a very thin circle off of that, then the next figure that you would see would be another circle. But that circle is going to be slightly smaller than the previous one. And we can continue to do this, and hopefully we see that we'll end up with a bunch of circles. Doesn't matter where we stop it, we're always going to end up with a circle. All right, so then how would I find the volume of that figure? Well, in order to find the volume of that figure, I would add up the area of each of those circles. What's the area of a circle? Pi r squared. And what would the radius be? The radius would be from the x-axis here all the way up to the function. That would be my radius. And in this case would be my value of f of x. So if I integrate from this value of a to b of each of these areas of the circle, which would be pi r squared, where r is the value of the function, dx, I would get the volume of that figure. Now I'm going to go ahead and switch to another figure. If it wants to work for me. There we go. So here we have f of x equals 1/8 times x squared times the square root of 2 minus x. Not a major thing that you know the equation of that, but notice the figure that I've got. So I'm going to integrate, I'm going to revolve from this point to this point, from my a to my b value, and we again revolve that around the x-axis very quickly. So as I revolve that, and it fills in there, again, I want you to think about your eyes being on the x-axis, out here to about 3. And if you're looking at that picture, approximately what kind of figure would you see? You would see probably a circle. And as you peel away circles, you'd see more circles. So as we sweep a disc there, hopefully you see that we have a circle at any point in time across that figure. So again, how would we find the volume of this? Well, if I have a bunch of circles, remember we can take infinite number of circles in there, and to do that we would take the integration from that a value to b times pi r squared, where pi r squared is the area of each of those circles. Well, what is the radius? Well, again, the radius is going to be from the x-axis up to that function f of x. So if I take pi times f of x squared, that's going to give me the volume of this figure. We're going to go ahead and look at another one here. Here we have e to the negative x plus 3. Again, I'm going to revolve this region about the x-axis. We're going to end up with a three-dimensional figure. And again, I want you to think about your eyes being on this x-axis, looking in to this figure, and hopefully you see that we have, again, a circle. And we should be able to peel, again, more of these circles off, infinite number of circles, and be able to find the volume of this figure. So again, we should see that we have a bunch of circles. Doesn't matter where I stop it, we still see a circle. And to find the volume of that, we're going to take the integration, again, from a to b of pi r squared, because pi r squared is the area of each of these circles. If I add all of them up, which I can do through the integration process, I'm going to find the volume of this figure. And let's pick just one more. Oh, we did that one. Find one we didn't do here. There we go. Here we have the square root of x. Again, if we go from this point to this point, we revolve this about the x-axis. We see our figure filling in. As I sweep, I should be able to see that I've got, again, a bunch of circles. As I'm looking at that x-axis, we see that the radius of that circle is from the x-axis up to my function f of x. And that's going to be what we're going to be able to find the volume of in our lesson today.